For more than a century, car factories have followed roughly the same basic formula. Manufacture hundreds or even thousands of separate metal parts, then use robots and workers to weld and assemble them into a finished vehicle. Tesla is challenging that entire system with a machine called the Giga Press 4.0. Instead of joining hundreds of components together, the machine can cast huge sections of a vehicle as a single piece in roughly one 90-second cycle. That means fewer parts, fewer welds, fewer robots, less factory space, and potentially much lower production costs. But what makes this technology so important? And why can't every automaker simply buy the same machine and start doing the same thing? Breaking a 100-year-old manufacturing system. Traditional car production is incredibly complex. A vehicle can contain hundreds or thousands of individual metal components. Each part must be stamped, shaped, transported, positioned, and finally connected to other parts. Robots perform thousands of welding operations to turn those pieces into a complete vehicle. The system works, but it is expensive and complicated. Every additional part requires another manufacturing step. Every weld requires equipment. Every robot needs electricity, maintenance, programming, and space. Tesla looked at this process and asked a simple question. If hundreds of small pieces eventually become one large structure, why not manufacture that structure as one piece in the first place? That idea led to the development of the Giga Press. However, producing extremely large aluminum components creates a major engineering challenge. Warping. The problem with large aluminum castings. Normally, large aluminum components require heat treatment after casting. The part is heated to a high temperature and then cooled rapidly to improve its strength. The problem is that a huge piece of metal does not cool evenly. Some areas shrink faster than others, causing the component to bend or twist. Even a few millimeters of distortion can make a part unusable, because automotive assembly requires extremely precise dimensions. Robots need every component to line up correctly. If a large structural part is slightly warped, it may not fit with the rest of the vehicle, potentially stopping the production line. This is one reason the idea of casting a massive section of a vehicle as a single component was considered extremely difficult. Tesla's approach was different. Instead of simply building a better heat treatment system, Tesla worked on the material itself. The alloy makes the difference. Tesla developed specialized aluminum alloys designed to achieve the necessary strength without relying on the traditional heat treatment process. The alloy contains carefully selected elements, each serving a specific purpose. Silicon, for example, helps the molten aluminum flow smoothly through the mold. This is critical because the metal must quickly fill narrow passages and complex sections before it begins to solidify. Manganese helps prevent the molten aluminum from sticking to the steel mold. Without controlling this problem, the casting could damage both the part and the expensive machine. Then there are tiny amounts of elements such as vanadium, titanium, and zirconium. These help control the aluminum's internal crystal structure as it cools, improving its strength and stability. The result is more than just a giant casting machine. Tesla is combining a specialized alloy with enormous casting pressure, advanced engineering, and automated manufacturing to replace many traditional production steps with a single operation. Why it matters. The real advantage of the Giga Press isn't simply that it can make a large piece of metal. It can dramatically reduce the number of components required to build a vehicle. Instead of manufacturing dozens of separate pieces and welding them together, a large structural section can potentially be produced as one component. That means fewer parts to manufacture, fewer robots to operate, fewer welds to perform, less factory space, and fewer opportunities for assembly errors. And this is where the technology becomes much bigger than one machine. Tesla's goal is essentially to simplify the automobile itself by simplifying the way it is manufactured. If this approach continues to improve, future factories could look very different from the giant, robot-filled plants that have dominated the automotive industry for decades. The Giga Press represents a fundamental change in thinking. Don't build a car from thousands of pieces. if you can build major parts of it as one. That simple idea could reduce manufacturing costs, speed up production, and force the entire automotive industry to rethink a process that has remained largely unchanged for more than 100 years. And that's why the Giga Press isn't just another factory machine. It could be a glimpse of what the next generation of automobile manufacturing looks like. The result is similar to what traditional heat treatment was designed to achieve, but the difference is that the metal can develop these properties naturally at room temperature. The aluminum comes out strong, slightly flexible, and with very low internal stress. This greatly reduces warping and allows the finished component to move directly into automated assembly. And this is where the technology becomes difficult for competitors to copy. Other automakers can buy the same type of giant casting press from the Italian company that manufactures it. They can have the same machine and similar production capabilities. But the machine alone isn't enough. Tesla's advantage also comes from its specialized aluminum alloy and the manufacturing process designed around it. In other words, competitors can buy the equipment, but they don't automatically have the material technology that makes the process work. And the alloy is only half the story. The metal explosion traditional casting usually relies on gravity. Molten metal is poured slowly into a mold and allowed to fill the space. That works for smaller components, but a vehicle-sized casting creates a completely different challenge. The moment molten aluminum touches the cooler steel walls of the mold, it begins to lose heat. If the metal moves too slowly, parts of it can start solidifying before the entire mold is filled. When two partially frozen streams meet, they may not fuse properly. Instead, they can create a weak internal seam that can make the entire component unusable. So the Giga Press doesn't simply pour the aluminum. It injects it at extremely high speed. Around 100 kilograms of superheated liquid aluminum can be pushed into the mold in a fraction of a second. The goal is to fill every corner and channel before the metal has time to freeze. But moving metal that quickly creates another problem: air. Imagine water rushing through a powerful fire hose. It becomes turbulent and can trap air. Molten aluminum can behave in a similar way. If air remains inside the mold, the rapidly moving metal can trap it inside the casting. Those tiny air pockets may remain hidden within the finished component. The dangerous part is that the outside of the part can look completely perfect, even when internal defects exist. To reduce this risk, Tesla uses a vacuum-assisted casting process. Before the aluminum is injected, the sealed mold has most of its air removed. More than 99.9% of the air can be extracted, creating an extremely low-pressure environment inside the mold. With almost no air present, the molten aluminum can move more smoothly, and there is far less opportunity for bubbles to become trapped. The process then happens extremely quickly. Air is removed. Molten aluminum is injected. Massive pressure holds the metal in place. The finished component is released by automation. The entire cycle can take less than 90 seconds. This turns a traditionally complicated and difficult casting process into something much more consistent and repeatable. The numbers tell the story. The real impact becomes clear when you look at what the Giga Press can replace. Instead of manufacturing and welding dozens of individual structural components, a large number of parts can be combined into one massive aluminum casting. That can eliminate many separate manufacturing steps, reduce welding operations, and dramatically lower the number of robots needed on the production line. The result is potentially a major reduction in the cost of manufacturing the vehicle's structure. And this is much more significant than saving a few dollars per component. In an industry where manufacturers constantly compete to reduce costs by tiny amounts, a major reduction in structural manufacturing costs can change the economics of an entire vehicle. But the benefits don't stop with cost. Fewer individual parts mean fewer joints. Fewer joints can mean fewer potential failure points, less vibration, and potentially less road noise. A more integrated structure can also make the body stiffer and more efficient to manufacture. So the biggest advantage isn't simply that the car becomes cheaper. The same manufacturing approach can potentially make it simpler, stronger, and faster to build. That's what makes the Giga Press so disruptive. Traditional manufacturing often forces automakers to choose between lower costs and better engineering. Tesla's approach tries to achieve both by fundamentally changing how the vehicle is assembled in the first place. And that is why the Giga Press is not just a giant machine. It represents a completely different way of thinking about automobile manufacturing. Normally, when something becomes cheaper, you expect some compromise in quality. But with the Giga Press, the idea is different. Lower manufacturing costs can also mean a stronger and more advanced vehicle structure. However, there is a major downside that often gets overlooked. That huge reduction in manufacturing cost can create a problem for the person who owns the car after an accident. The repair problem. Under the traditional method of building cars, the body is made from many separate sections. If one area is damaged in a crash, a repair shop can often cut out the damaged section and weld in a replacement. It may be inconvenient, but the repair can usually be completed without replacing the entire vehicle structure. A massive single-piece casting changes that equation. If a large front or rear section of the vehicle is made from one continuous piece of specialized aluminum, repairing it becomes much more difficult. You can't simply bend the metal back into shape, and welding or heavily modifying the casting can compromise its structural integrity. That creates a serious problem for insurance companies. If a major casting is badly damaged, even in what might appear to be a relatively moderate accident, repairing the vehicle may not make financial or safety sense. In some cases, the insurer may have little choice but to declare the entire vehicle a total loss. This issue has become increasingly important in markets such as China, where electric vehicles with large cast components are becoming more common. A vehicle can perform extremely well in a major crash and still become economically impossible to repair after a smaller accident that damages a critical structural component. Tesla has tried to address this by designing replaceable sections and crumple zones around the large castings. These areas are intended to absorb smaller impacts without damaging the main structural component. That helps, but it doesn't completely remove the problem, and it highlights an important trade-off. The manufacturing process is optimized to make the vehicle cheaper and faster to produce, but that same design can make certain repairs more complicated and expensive later in the vehicle's life. Why competitors can't simply copy Tesla? This is where the Giga Press becomes more than just a giant factory machine. Other manufacturers can purchase similar casting equipment, but owning the machine doesn't automatically give them Tesla's entire manufacturing system. Toyota, for example, has explored its own gigacasting strategy and has demonstrated systems designed for very fast mold changes. But Toyota has taken a somewhat different approach, using several smaller modular castings rather than putting everything into one enormous component. That approach can make repairs easier and preserve more flexibility for its existing manufacturing and dealer network. The downside is that using more pieces also means more connections, more processes, and potentially fewer of the cost savings offered by a single massive casting. Meanwhile, companies such as BYD are aggressively adopting large casting technology as they compete in China's highly competitive electric vehicle market. But there is one thing none of these companies can simply copy overnight. The machine is only the visible part of the technology. Behind it is an entire manufacturing ecosystem. There is the specialized alloy chemistry, the vacuum system that reduces defects, the precise timing required to inject the metal, and the vehicle design itself. The cars have to be engineered from the beginning around these massive castings. A traditional automaker can't simply take an existing vehicle, remove its welding robots, and install a Giga Press. Their vehicles were designed around hundreds of individual parts. Their factories were built around welding and assembly lines. Their suppliers, workers, production systems, and cost structures are all based on the traditional approach. To completely adopt gigacasting, they would have to redesign vehicles, rebuild factories, change their supply chains, and retrain their workforce, all while continuing to produce and sell their existing cars. That's an enormous transition. So buying the same press doesn't make a company equal to Tesla. The machine is only one piece of the puzzle. The real battle is cost. When you step back and look at the bigger picture, the Giga Press isn't really about building cars a little faster. It's about cost. In the automotive industry, the company that can manufacture a vehicle for less money has enormous strategic power. It can reduce prices, attract more customers, increase market share, and still have money available to invest in the next generation of vehicles and factories. Tesla has repeatedly used price reductions to pressure competitors and force the industry to respond. If Gigacasting can deliver the kind of major structural cost reduction Tesla is targeting, the advantage could become even more significant. And that's the real story behind the Giga Press 4.0. It isn't simply a giant machine replacing hundreds of smaller ones. It's part of a much larger strategy to redesign the vehicle, simplify the factory, reduce production costs, and ultimately change the economics of building an automobile. The companies that master the entire system, not just the machine, could have a major advantage in the next generation of the automotive industry. The advantage created by the Giga Press could become a powerful competitive moat, growing stronger as the technology improves. But the impact doesn't stop at Tesla. Once one company proves that cars can be built at significantly lower cost, every other automaker has to respond. The problem for traditional automakers companies like Ford and General Motors have spent decades and billions of dollars building traditional factories. These massive plants are filled with stamping machines, welding lines, thousands of robots, and complex systems designed to assemble cars from hundreds of separate parts. Replacing those factories would cost an enormous amount of money. So, if Tesla can significantly reduce the cost of a vehicle structure, traditional automakers can't simply copy the change overnight. They would have to redesign vehicles, rebuild factories, change production systems, and retrain workers, all while continuing to sell their existing cars. It's like trying to rebuild an airplane engine while the plane is still flying. If they move too slowly, they risk losing customers to manufacturers with lower production costs. But if they move too quickly, the huge investment required to rebuild everything could create serious financial pressure. Why Gigacasting is spreading. That's why Gigacasting is spreading throughout the automotive industry, despite its disadvantages. It isn't necessarily because every automaker loves the technology. It's because once a cheaper manufacturing method becomes available, companies that don't adopt it risk falling behind. The pressure is especially strong in China, where electric vehicle manufacturers are fighting an intense price war. For these companies, reducing a major part of production costs isn't just a small advantage. It can be essential for survival. That's why Chinese automakers and suppliers are developing their own large-scale casting systems. What started as a major Tesla advantage is increasingly becoming an important part of competing in the EV market. The hidden winner. There's another consequence that is easy to miss. The biggest long-term winner may not be a car company at all. Removing hundreds of welding robots doesn't just save money. It can completely change the design of a factory. Traditional car plants need enormous buildings filled with robots, welding equipment, assembly stations, workers, and complex logistics. A factory based on large castings can potentially be smaller, simpler, and less crowded. And if manufacturing becomes simpler, the barrier to entering the automotive industry could also fall. For more than 100 years, building cars at scale has required enormous factories, huge investments, complicated supply chains, and highly specialized production systems. But if major sections of a vehicle can be produced as a few large castings, the entire process could become much easier to manage. That could eventually lead to new manufacturers, faster development cycles, and completely different approaches to vehicle design. In other words, the Giga Press isn't just changing how Tesla builds cars. It could change what it takes to become a car company. The choice ahead. The automotive industry now faces a difficult trade-off. Manufacturers can focus on cars that are cheaper and faster to produce, even if some repairs become more difficult. Or they can continue with vehicles that may be easier to repair, but are more expensive and complicated to manufacture. Getting both advantages at the same time won't always be easy. The companies that make the right decisions could determine who remains competitive over the next decade. That's the real story behind the Giga Press. It isn't simply a giant machine replacing welding robots. It represents a challenge to a manufacturing system that has remained largely unchanged for more than a century. If large-scale casting continues to spread, it could reduce production costs, simplify factories, and force every major automaker to rethink how vehicles are designed and built. But there is another question waiting on the other side. What happens to repairability and the used car market? If major structural components become harder to repair, insurance costs, vehicle lifespans, and second-hand car prices could all be affected. So here's the question. Would you buy a car with an excellent safety rating if a relatively small accident could make it too expensive to repair? Or would you pay more for a car that is easier and cheaper to fix? There may be no perfect answer, but the choice could become increasingly important as the automotive industry moves toward a new generation of manufacturing.